right, we are going to be adding polynomials. This is not really different from adding monomials. It's just longer. So we just got to, have some strategies to tackle these longer problems, okay? So just a quick review first. Remember like terms. Like terms have the same variable and exponent. So for example, same variable and exponent, like 5x squared and 3x squared are like terms. Okay, a non-example would be, for example, 5x squared and 3x. Okay, why? Why are these not like terms? Because this one has an exponent of 2 and this one does not. Okay, another example would be, for example, negative 2a and 4a. These are like terms. Notice one's negative, one's positive. It doesn't matter. It just matters that they have the same variable, a, and exponent, which is in this case an invisible 1. Okay, it wouldn't be like terms if we had, for example, negative 2a and negative 2n. Okay, it doesn't matter that these two numbers are the same. What matters is that these are not the same variable, right? So again, these are the non-examples over here. These are not like terms. Okay, and finally, let's just like make it a little silly, right? If I had 37x, it doesn't matter what this number is. It could be 45x. It doesn't matter that one's negative, one's positive. It doesn't matter that they're big numbers. Again, we're just looking here. Look, let's even mix it up. Let's make these x to the third. Okay, those would not be, those would be like terms, whereas over here, these would not be. And this is where you got to be like really careful because it's just, we tend to read things fast. Like these are the ones that we kind of tend to mix up. Like we're just not paying attention. This is a 3, this is a 2. So just careful, okay? Take a super fast moment to just pause the video and go ahead and match these, right? Just to give yourself that second of processing time. All right, so hopefully you matched 4x and negative 9x, 5n squared and n squared. Okay, right? This is a 1n squared, and then negative 3n and 5n. Those are like terms. Okay, so when we're adding polynomials, here's the deal. Like, ooh, parentheses, what's all this? They literally mean nothing. Okay, and the reason is, like, what I'm saying is, hey, I want to add all this stuff to all this stuff. And like what we're going to do is like pretend like this is in a basket and this is in a basket. Like we're just going to dump the baskets together. So it doesn't matter where the baskets are. Okay, it just doesn't. So we're going to see that those parentheses do matter when we start subtracting. But for right now, they just really don't. Okay, and then when we see the word sum, sum means the answer to an addition problem. So if I say, what's the sum of 3 and 5? That just means add 3 and 5. What do you get? Oh, it's 8. Okay, so let's take a look at a couple examples. So here, the parentheses, they really don't mean anything. I'm adding this and adding this. I could tell you like, oh, rewrite it without the parentheses, right? 3n squared minus 6n plus 9 plus 4n squared plus 5n plus 3, and just rewrite the whole thing without the parentheses. But that just seems like a waste of your time. So we're just going to find our like terms and combine them. So what's like terms with this? The other 4n squared. What's like terms with this? The other term with the n. What's like terms with this 9? This other term with no n. Okay, so let's combine. 3n squared plus 4n squared is 7n squared. This is negative 6 plus 5. Okay, so look, that's this, right? That's negative 6. 1, 2, 3, 4, 5. Oops, I had drawn 7. Okay, so look, this is 0, 0, 0, 0, 0. I'm left with negative 1. This is negative 1n. You could write it with a negative 1 there. It doesn't matter. Or you could just write negative n. And then 9 plus 3 is 12. Okay, done. Notice I did it in one step. Could you have rewritten it without the parentheses if they were throwing you off? Yeah, sure. Seems a little unnecessary. Okay. Over here, when you go ahead and to do the practice, just make sure, look, you're going to notice there's 3 terms here and 2 over here. So there's actually one term that doesn't have a like term. We would just bring that down. Okay. Find the sum of x squared plus 5x minus 7 and 4x squared minus 8. Okay, now look, I'm going to show you. I could write this out and say, okay, I'm finding the sum. So I'm writing like this, and I could write it out like this, okay, and then you can underline the like terms and do the math, okay? If I'm being lazy though, I'm honestly just skipping this step and just underlining my like terms right here. I'm finding the sum. Okay, you're gonna see we're gonna have to do a little bit more when we get to subtraction, but for the sum and the adding, it's like, not too bad, right? This is 4x squared plus 1x squared. That's 5x squared. Okay, I could have caught those same 2 terms here. This is 5x doesn't have any like terms. I'm just going to bring that down, right? I could have got that same term here. And then this is negative 7 minus 8, right? I could have caught these same two terms here. That's 7 negatives, 8 more negatives for a total of 15 negatives. Okay, so this step is optional, but you know, do what works for you. Okay, go ahead and pause the video. Try these two problems real quick. Okay, I'm going to just model them really quick. Notice I have a note down here. Make sure you write your answer in standard form, meaning the largest exponent is first, followed by the next largest exponent, followed by the constant that has no variable at all. Okay, I'm just going to really quick show you these two practice problems. This was 5a to the third plus 2a to the third, 7a to the third. Make sure you catch that's a 3, not a 2. This one doesn't have any like terms. And then negative 5 plus 9 is positive 4. Okay, sorry about that. And then over here, I'm not going to rewrite it. I'm going to just find my like terms. This is 5x squared plus 1x squared. That's 6x squared. Negative 8 minus 2 is negative 10, right? 8 negatives, 2 more negatives. And finally, 10 minus 4 is positive 6. All right, so hopefully you have a good idea about that. And then you are, those are the answers. You are going to go ahead and try the problems on the back.